Hey guys, it's Mr. Rysz. I'm recording this again because the first time I recorded, I noticed the screen annotations never saved. So let's go ahead and get this started. We're going to start with the Chapter 1 notes and begin here. So here we go. This is P1, not Chapter 1. So this is the pre-calculus chapter. We're going to start the Section 1 notes. We'll go through the first three objectives here. So we'll sketch a graph of the equation, find the intercepts of the graph, and we'll test for symmetry with the axes and the origin. So a couple things here to go through the notes, and feel free, I'll read through them, but you guys can go through this. So just remember that any point is a solution point. So a function here is a series of points that all work together, where when you plug in the x value and plug in the y value, it makes a true statement. So we can always think up as a function as just a table of solution points. And once we visualize that table, so this table here, we can plot it out and it makes a graph. So that kind of helps us out when we remember exactly what a graph is and what it tells us. So if we want to sketch a graph here of this equation, all we need to do, and I'm going to double check that I do this right, is to annotate this here. There we go. And we'll draw. Is to remember, okay, we can always take a table here. And so let's make a table here, x and y. All right, I'm going to start here in the middle with 0, and then go 1, 2, and then -1, -2. We're going to plug those in and see what happens. If I plug 0 in, that's an easy one, I'll get -2. If I plug 1 in, 1 squared minus 2 is -1. I'm going to get the same thing on -1. If I plug 2 in, 2 squared is 4, minus 2 is 2. And all we're going to do is take those collection of points and plot that in a graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just keeping the axes the same to make everything nice and neat. And plot those points. We got a point at -2, +2. Point at -1, -1. 0, -2. So this function here is just a visualization of all the solution points. And the one thing nice too is like there is a solution like technically here at like 1.5, like whatever that was. We're just showing where all the solutions. So technically his line is a whole bunch of points all just put next to each other with 0 space in between them. There we go. Okay. Next we're going to look at the intercepts of the drawing. So the intercepts are the x and y locations, or the location where the line crosses the x and y axis. An easy way to find the x-intercept is to make the y 0, and it's the x number there, or the x value. And the y-intercept is when the x equals 0, and it's the y value that we get. So the one thing about some functions here is some functions can have multiple answers, so multiple intercepts. So like this function here has just one y-intercept, but it never crosses the x-axis, so it has no x-intercepts. This function here has 3 x-intercepts. It crosses the x-axis 1, 2, 3 times, and also crosses the y-axis right here at 0. So you can have multiple x's and multiple y's, and you can actually have none of each. So if we go through this example here, find the x and y intercepts of y equals x cubed minus 4x. We're going to go ahead and make a little table here, and let's begin this. So let's start off with the easy one. Let's start off with the y-axis. So the y-axis here, easiest way to do that is to make the x equals 0 and solve for y. So y equals 0 cubed minus 4 times 0. Well, that'd be 0 cubed is 0, 4 times 0 is 0, 0 minus 0 is 0. Oh, yo. So that means we would have a y-intercept at 0 when x is 0, or y would equal 0. So at 0, 0. Now the x-axis, we're going to make the y equal to 0 and solve for the x value, or values in this case. So each equation we can have different things. We just got to remember the process here. We have a cubed equation, so we're going to try to do some factoring if we can. So we can factor out an x, and this becomes x squared minus 4. And we can actually keep factoring that. X plus 2, x minus 2. And then once we have a factor, we set each section equal to 0 and solve for that. So when does x equal 0? Well, that's when x equals 0. When does x plus 2 equal 0? When that's x equals negative 2. And when does x minus 2 equal 0? That's when x equals positive 2. So we have 3 locations that crosses the x-axis. So when x is 0, y is 0, which matches the y-axis. That makes sense. When x is negative 2, y would be 0. And when x is positive 2, our y would be 0. So that's how we get all those. Okay. All right, let's clear it off here and keep moving with the mouse. And the next thing, symmetry. So symmetric equations are easy to look at a graph. I'm pretty sure you guys know symmetry, like with animals. You can see like the human body is pretty much a y-axis symmetry. Most of us are the same on the left and right. We mirror each other. X-axis would be split left and right. So maybe something like a starfish. Well, not even a six-legged starfish. And then symmetric through the origin, goes straight across. The way that we find this graphically is if we have y-axis, if we make the x negative, we get the exact same equation. If we have x-axis, we make the y negative and it reflects over on the same point. And then origin is if we make both of them negative, we reflect on the same point. So you can see here a negative x